Good morning, everyone. This is Julie McDonald with Microcom Technologies, and I'd like to thank all of you for attending today's webinar with MetaGeek. Today's host is Trent Cutler, and he is their product manager and will be presenting today. If anyone has any questions, please submit them in the question box, and Trent will answer them at the end of today's presentation. Trent, we're so happy to have you back. I will say we haven't had a MetaGeek webinar in quite a while, and we're very, very happy to have you back with us here today. I am finished for now. Please go ahead and take it on over.
Great, thank you very much. So today I want to talk about MetaGeek's latest product, which really kind of is an evolution of all their products combined. MetaGeek has been around for quite some time now. They've made a USB spectrum analyzer known as the Wi-Fi, and that was very successful for troubleshooting. And they also make a Wi-Fi scanner called Insider, which is commonly used on Windows machines for troubleshooting Wi-Fi signal strength issues. And so I'm here to kind of talk about what all of these things do, what your customers can benefit from in terms of this. Some of this will be a little bit technical, but what I'm hoping is that you can kind of use some of the language that I provide here to communicate with your customers about certain symptoms they may experience on their Wi-Fi networks and how this tool can help them. So let me just introduce myself real quick. So I'm a product manager at Auvik. Auvik recently acquired MetaGeek. I was one of the original MetaGeek employees way back in the day, and some of you may remember me doing similar presentations to this one. And I rejoined in September of 2022, and I reside in Salt Lake City. So Auvik, they kind of have a mascot. So there's a polar bear, and it's in all of our things. It's kind of well beloved by all of the customers, so that's why we have a polar bear in these examples. So what we're going to cover today, we're going to cover Wi-Fi scanners, spectrum analyzers. We'll talk about the next generation of Wi-Fi channel analysis, and then we'll talk about sticky clients and their impacts to conference rooms. Now, your customers, they may have wireless issues. They may not know exactly how to resolve them. I actually have some tips on how to do some of these things, and I also have some good screenshots of this. I don't have a live demo ready for this presentation, but I'm happy to answer the questions and schedule any follow-ups that you may have later. Okay, so not everyone knows what wireless interference is. You may have an idea, but for Wi-Fi, Wi-Fi uses the public ISM band, the 2.4 gigahertz range. It's a small segment of what is available, but basically it's a little bit, it's only regulated a little bit, which means any device can use it. And one of those devices is going to be a Wi-Fi network, and it competes for spectrum with other things like cordless phones or microwave ovens and other kind of things. Those things, when they are operating at the same time, transmitting at the same time, will cause the communication to break down. Now, we have had a tool that can show all of the transmissions from whatever device, non-Wi-Fi, and it can show where those frequencies overlap. But what do you do when interference isn't the problem? And here's an example, okay? So some of you may not understand what we're seeing here, and that's okay. Our tools are very helpful for customers because the one thing that we do really well is we have good visuals that help you understand what you're seeing. Okay, so the first thing in this left box is there's these little lines that are drawn here. This is a Wi-Fi network, and the channel that it is centered on is the Wi-Fi channel that it has. That says, okay, this box is here. All the spectrum analysis data is in the background of this graphic, and we are just basically saying, whenever you see red, that's when you know that there is a lot of talking going on. There's congestion. Some of that may be Wi-Fi, some of it may not be. This box shape is actually the shape that Wi-Fi is going to make when it is operating on that frequency. And so if you look on channel 6 right here, you can see the box, And then you can kind of see a similar red pattern underneath that. And that is just, all it's doing is indicating that there is Wi-Fi traffic there and it's busy. Now, because the spectrum is shared, there's lots of devices talking on it, and each one of those devices has to take its turn. So the more devices you have on a channel, the less opportunities the less opportunities a device has to talk. Basically, all we're saying is a channel is a pie, and the more people that are going after that pie, the smaller slice for you. Okay. So people have used the spectrum analyzer to one, do congestion analysis. You go into an environment and you say, well, let's open up a spectrum analyzer and see how busy things are. Sometimes you would see a spike like this and like this right in the center of the Wi-Fi network graph right here, and you would say, oh, that doesn't look like Wi-Fi, probably causing some interference issue. So that's the 2.4 gigahertz. I've added in some commentary here and there, but basically we're saying, hey, we saw that the strongest signal in the 2.4 gigahertz is -52 dBm. If you don't know what that means, doesn't matter, that's good. And in the 5 gigahertz, so we have a lot more channels and we have a lot more spectrum. You can see that we actually have some high signal strength. So the taller the box, that means it's a good signal. You can notice that one of the tallest boxes that we have is not fully congested like we see with some of the other ones here. So this tool, it's a phenomenal tool because it can help you make better channel decisions by looking at the raw spectrum, and you see the signal strength of the network, and you also are able to say how busy it is. Right now we say the signal strength is -40, so that's a good strong number, and it's not busy. That's enough for a lot of people to go into an environment and make some adjustments to a Wi-Fi network so that client devices don't experience congestion. Now, what we don't see here is, and what we don't know, what we don't have context around is, well, what is the client device and what radios are these? And that's what I'm here to talk to all of you today, because MetaGeek has been doing this spectrum view and then the signal strength view for a long time, and we've been doing some good packet capture visuals as well. But now we have a tool that takes all of that and puts it into one single software application that has a bunch of the intelligence that MetaGeek has acquired over the years and puts that into events. So let's say, for example, your customer says, I have Wi-Fi issues everywhere. We've built a tool that you plug in a bunch of adapters, and I'll hold this up if you can see my camera, and I'm not sure if this will be part of the recording here, but I'll hold this up if you can. If not, I've got a picture of it later. You put in some adapters to a laptop device, and those adapters, we are most likely you're going to need 3, but one of those adapters is going to be set to the channel of the device that you're troubleshooting. So it's going to lock in on it. And then we take the remaining 2 adapters and we say, go hunt on this network and all the channels that you see the network on. Go hunt for where this device is going to roam. Okay. So our tool is all of a sudden incredibly smart, and it can follow a device wherever it goes. And what happens is we can actually see failed connections and get the reason codes that the device or the infrastructure provide in a PCAP. Now, if you've used Wireshark, you know that this is like hunting for a needle in a haystack. Okay. So you can actually see that these events come in. We can see that the device disconnected, and we can actually see who sent it. So what this is and I've just kind of built this out so some of you guys have an idea of what this tool is like. This tool does spectrum analysis visualizations, and it also takes standard USB Wi-Fi adapters, of which you can buy outside of MetaGeek if you want. But what this looks like, it's a $500 annual tonic subscription. If you already have a Windows laptop, you're good to go. But if you are building up a tool for like a technician of some sorts, this is all that you need. you need some sort of Windows laptop that is a little bit more than just the basic, and then a ruggedized case, 3 Wi-Fi adapters, and a USB-C hub that supports USB-A. Okay, that's it. So your customers, if you can go to them and say, hey, if you need some Wi-Fi troubleshooting tool, this is basically all that you need to start following device. And actually, this is the same tool that a lot of professionals use and the consultants. So if your customer is like, man, we've had these consultants come in, they haven't solved the problem, is like, actually, I can get you the same software, and this is exactly what is needed to do. All right, so we're going to talk about a Wi-Fi issue in an environment. Now, users are mobile. That's the whole point of Wi-Fi. It allows you to take a laptop, a smartphone, wherever you go, and troubleshoot it. Okay, so a user gets out of the elevator, and the first access point he sees is this one, and this is the access point that is the conference room access point, right? Except the conference room is right next to the elevator, and then the user gets out of the elevator, his device connects, and the first AP he sees is the conference room. And then that user continues to walk down the hallway and over here. And he still is connected to that one. Now, why is that device still connected to that access point way over there? Well, the reality is he still has sufficient signal. They've programmed that device to say, if you've still got a signal, there's no reason for you to kind of disrupt that. Except one of the problems with all of this is if the device didn't roam, what is the connection like, and how good is it actually? Is it as fast as it possibly could be? Well, what happens from that point on is when you have a lower signal strength, you get slower data rates. So the device that's all the way over here, it's going to be talking slower and slower, and sometimes they may have to send something again. And we measure those in terms of retransmissions. So not just a transmission, but how many times are we having to send that packet again? Okay, so a device gets further away from the access point, and I may have mentioned that like a Wi-Fi channel, it's shared. So all the devices in the conference room, all these desks here, all these smaller conference rooms, they're all sharing that channel for this AP over here, okay? Now, if devices walk by that conference room and don't roam, we call these sticky clients. It is sticky because it's not roaming to AP2 or even AP1. It stays with the access point that it first saw. This is kind of, sometimes it can be called a point of attachment issue, but this is a normal thing. So how our tool visualizes that is you'll see the signal strength, which is right here. It gets down to about -82. And the overall connection, so our tool, again, scanning all of the Wi-Fi channels. So we lock one onto the device, and then we use the other adapters to measure the signal strength across the entire environment, the entire network. So what we say is, hey, you've got network coverage here that is better than what you are connected to, period. And so you can see this device, as it was walking down the hallway, got to a very low signal strength, and then the data rate was very low, about 1 megabit per second, okay? And then above, we see the retry rates spiked. So one, it's talking slow, and it's repeating itself about 70% of the time, okay? Now, this is not something that this is something that a pro would show you or your customer, but this is something that actually we've built the intelligence around, that you just take a laptop and plug in the USB adapters and it will auto follow MAC address. As soon as you click on it, we've done all the stuff in the background. We're gonna follow it as it roams around. So we're measuring the retransmission rates, and we're measuring how often a device roams. This is great for really understanding how well a device works and functions in a Wi-Fi network, but also there are some things that we can fix and resolve here just with this knowledge that we see here. Okay, all right, so what this tool does, we take Wi-Fi USB adapters, we take all of the MAC addresses, all the radios that are transmitting, even your neighbor radios that may be causing congestion, and we start building an intelligence model inside the application. And every single device, no matter what it's doing, we're going to track its behavior. So on the left-hand side of this, we're going to say, hey, we discovered a client, we assumed that it connected, and then we saw that it probed, and then we saw that it roamed, and we see that it probed again. Now, a probe is just basically saying, it's a device saying, hey, I may have a low signal strength. I'm curious to see if anyone is out there that can provide something better. Okay, that's all a probe is. So every single time before a device roams, it's going to probe. So it's going to say, hey, anyone out there? And the access points in the infrastructure. So some of you may know those as wireless routers. Those are the things up in the ceilings. Those things are going to hear that probe and then be like, oh, I got you, I'm here. Okay, so that's how the device is going to roam. And then you'll notice the behavior that we talked about earlier as a device, as a signal strength that a device is connected to, okay? Remember, we follow the device. You can see the signal strength of the client device. Since we're following it, it remains about the same. It's very high, -26. But the AP that it's connected to, because we follow it, we know that it is connected to that one near the conference room. We see it drop all the way to -72. And we also see the retransmissions, the retries, increase up to -67. That's normal behavior of Wi-Fi. So if some sort of device is able to just maybe, say, hey, I'm having to repeat myself a fair amount. Like I'm having to repeat myself. Is there something better out there? That's when it's going to roam. Okay. So let's go back to this example that we have. And I just want to touch on this a little bit because your customers are going to know exactly what I'm talking about right here, because they'll look at their map in their infrastructure where they monitor all their Wi-Fi access points, and they're going to say, oh yeah, I've got one AP that has all the clients, and then I've got one that has two. So each of these numbers is just kind of, it's a representation of what a lot of Wi-Fi administrators see all the time. Like, I don't know why, but there's just like 26 devices on this one, which is the conference room, which is the one everyone complains about. And then there's two here, okay? And, when you take a path like that, it's just, and I'll go back, when devices are taking a path, they are not roaming from the first Wi-Fi access point that they hear. So how does this play out? Well, when you are measuring something with a tool like our tool, okay, and historically our Wi-Fi scanner did some of this too, but you didn't get to see what it looked like from the user experience. You had to make assumptions. You had to say, well, I think it's doing this, or you would open up a Wi-Fi scanner and you'd be like, you've got good signal strength. I don't know why that device is misbehaving, okay? Now we can actually see that maybe it's staying connected because the retry rates aren't going up enough, okay? And so one of the things that you can do is you can start changing and optimizing the transmit power of an access point. So if you were to change that transmit power so that it is not as loud in that little thing, then maybe the retry rates of that client device will spike and it will start to roam a little bit more. Or maybe you say, you know what, I see it going down to these low data rates. And those low data rates are causing problems for everyone that is connected to AP3. These guys that are on the cell edge further far away, like over here in these seats, they're far away, they talk slow, they repeat themselves, and it's causing issues for all the video calls in this conference room. What if we no longer support the lower data rates and we trim back the transmit power so it's not going as far? That will force the devices that come in and roam around. They come in, they see the first access point, and they stay connected. Those sticky clients. What if the solution is that? So when you talk to customers, one of the things that you can say is like, hey, like if you've got issues that are everywhere or in certain little pockets and you're not exactly sure why clients are so sticky, or maybe you have a client that says it has low signal strength, but there's an access point right above their head. This is the tool that's actually going to have the capability to see exactly why and help you make those fine-tune optimizations. All right, here's another example. we add in an access point, but that didn't solve the problem. And in some cases, it might make the problem worse, okay? And this goes to that kind of congestion issue. So traffic is going to normally look like this, but we have the ability to see all the traffic, calculate the airtime of that traffic, and help you visualize, your customer visualize what may be causing congestion. So in this particular repeating GIF that I have, you'll notice that we identify traffic that is on the same channel but isn't part of the access point that you are looking at. In this particular example, we say, hey, there's about 50% of the airtime that's being consumed by neighbors, okay? So that means access points that don't broadcast the same SSID. And then the extended network, which is the other access points that may share a channel and are broadcasting the same network name, okay? So sometimes a customer may have unintentionally put access points on the same channel and not realize that like all of the APs and all their clients, so let's say you have 2 APs on the same channel and each AP has 25 client devices. Well, now you have 2 APs and 50 clients all sharing that pie. So the more devices on a channel, smaller slices, okay? So that pie analogy really works here because you notice, hey, it looks like a full pie, but really, when I start looking at all the neighbors and all the other stuff that's on this channel, the slice of pie that these devices is getting very small, okay? So this can start helping you make better channel choices for a Wi-Fi network, your customers. That's what that is designed to do. Okay, all right. So historically, MetaGeek products used to, we do a really good job with real-time signal strength. There are flavors of Insider that do have the spectrum analysis built in, but this is generally what the feature set looks like. We've got real-time signal strength, spectrum analysis. So whenever you hear spectrum analysis, just know that what's really happening is, if you need to know if there's interference that's happening, spectrum analysis is what your customer needs, okay? Most of the time, I tell someone that they need both. If they don't know what is causing performance issues, you just tell them, you need to figure out whether it's a device issue, a radio issue, a channel issue, or an interference issue. All those things really come down to a matrix that looks like this, okay? All right, so this is the same graph that we saw, but I added all the new functionality that is built into MetaGeek's tool called Tonic. Now, Tonic it's got all the functionality to take in spectrum analysis, do that as well. So if someone is set up to do spectrum analysis with a Wi-Fi device, they've got it. But it is also going to do PCAP analysis. So we can take a capture. If you need to export it to Wireshark, we got that. We also can do multiple channels at the same time. So, again, the Wi-Fi NICs, and I'll raise this again. These Wi-Fi NICs here, this is just a little, I'll show this. If you can see my screen, this is a Windows tablet, and I've got Wi-Fi NICs here. Very easy, very portable, but we're taking these 2 adapters and we're setting them to multiple channels so you can catch those roam events. So as the device is moving around, you just follow it with this laptop. So you can find devices. Now, some people, they don't know what a device is doing on their network, and they don't know how to find it. This tool can find devices. And again, the auto capture for following, if you are just clicking around, we're going to be adjusting stuff in the back end so that we can actually just follow the device that you care about. And then again, we measure channel congestion. And channel congestion is very, very useful for determining if a neighbor is stomping on your bandwidth or if you're stomping on yourself. So that's kind of the piece there. Most people, when they have Wi-Fi issues, they say, my vendor's pretty good, it works really well, but in this one area, it's not working. And some people will say, well, you got to look for interference. That's a great first step. But what if it isn't? What if it is, device is not roaming, or they're clinging on too long, or they're getting disconnected from the infrastructure for bad behavior? All of those things are things that this tool is capable of providing an answer for. and it is also capable of measuring the signal strength of anything that has a radio in a Wi-Fi environment. Okay, so here's just the basics of the software. So the org admin is going to own the license, and they can add or remove technicians as they need, but really it's just $500 per seat for a technician, and that's per year. It's a subscription. So one of the things that is nice about the subscriptions, and I know some people don't always like them, but one of the nice things is like if you have an issue and you just need to get it done, it's just a one-time hit, and then you don't need to resubscribe after that. But we think that the benefit of this tool is that any time that there is a Wi-Fi issue, you just investigate it. You walk up to it with a tablet and you just say, okay, let's figure out what's actually going on here. You click the MAC address and you start digging into it. So really one Wi-Fi adapter is required. I recommend 3. You can do 2. 1 is probably not going to get you any of that smart follow and roaming analysis. And then if you want to add the spectrum analysis, you can. My real honest take here is that we don't see interference like we used to a long time ago. Really, it's come down to like congestion, saturation of Wi-Fi environments. And so that's why a packet catcher tool is providing us better insights. We can actually know who the top talkers are and what neighbor is talking too much, and we can actually find those devices a little bit easier. Okay, so Julie, I'm done here. If we want to tackle any questions, that's great.
Thank you so much, Trent, for that wonderful presentation. And yes, we do have some questions here. Please excuse if some of the questions might be something you covered either a little bit or even more than just a little bit, but I'm going to ask them anyway. So let's get started with the first one. Here we go. Does the Spectrum device provide real-time data on Wi-Fi traffic, or does it require additional analysis after capturing the data?
Yeah, so great question, actually. So I'm going to make a distinction here, and I'll grab this one over here. So this, when we say Spectrum, this is the Spectrum Analyzer. It's $500 just for this device. Now, Spectrum Analyzers can be about $20,000. This is actually why this is popular. This can be done in real time with the tool Tonic. It can all be done in real time. And in fact, what is published now is real time. What is going to be released in a week or 2 will provide better capture playback. This one is not going to be able to say, it's not going to be able to find a specific device. It's not going to be able to say, this is the MAC address and this is the top talker. It's just going to basically say, this channel is too busy and there's too much RF activity here. These devices, these are about $80. It's a USB Wi-Fi adapter. It's Wi-Fi 6, not 6 gigahertz, but Wi-Fi 6. This device is able to look at the airtime, every single packet that is going across on that channel, and it's going to say, it's very busy here. These are real time, and it will provide a single file that you can do playback on. And the nice part about that is we are changing the licensing structure for Tonic, in which anyone will be able to open up the first 5 minutes. So if you do need to send these Tonic files back and forth to someone to just kind of review, be like, hey, I saw this over here. I don't know what's going on. Would you have a look at it? Those files should be open, can be opened by anyone, at least the first 5 minutes of it.
Excellent. Thank you so much, Trent. Next question here for you. Are there any specific scenarios or environments where the Spectrum device excels in providing insights into Wi-Fi traffic behavior? That sounds like a good one, right?
Yeah. So plenty of times, like in my particular career, this came in secondary, helpful. And what I mean by that is, like, if you don't have the Spectrum device, fine. Most likely you will see a client device like this laptop over here. In the tool, it will show a lot of retransmissions, meaning I sent something, it wasn't acknowledged back from an access point infrastructure, so I had to send it again. and again and again. We measure that with this. And when you see high signal strength and high retransmissions, you can sometimes just kind of know that there is interference, and you can make a channel adjustment to see if that fixes the problem. In a lot of cases, it will. If you need to find what is causing the interference, this is not going to help you, okay? So you can mitigate a problem with just this. But if that problem is persistent and you really need to figure out what it is, that's what this job is. I mean, the spectrum analyzer, that's what this job is for. So it's not a Wi-Fi device, but it is operating on a Wi-Fi channel, and you just need to figure out what it is. In my career, this has been, anything from like something that dries paint, machinery, heavy machinery that emits electromagnetic stuff, or I've seen analog video transmitters, things like that, that are just kind of in environments, and people forgot about them, and they were just plugged in, just broadcasting. And so being able to find it and just remove it, that made me look good, and it also solved the problem. So your customers, if they are dealing with some things and they do need a spectrum analyzer, this is just something that you just bundle in, and you just say, listen, all your bases are covered. You're going to need the spectrum and the Wi-Fi capture devices.
Thank you so much, Trent. Going on to the next question. How does the spectrum device handle interference from non-Wi-Fi sources, such as Bluetooth devices, microwaves, cordless phones? Can it identify and mitigate such interference?
Yeah, so it is going to show traffic from those. If you remember one of my slides, I showed some spikes that were red, but they weren't on the Wi-Fi channel. This was showing that, and the nice thing about it was like, hey, we validated that there is non-Wi-Fi stuff here, but it isn't on the same channel, and it was operating correctly. But all of those devices will show up with this. And the nice thing is you can say, yep, it's here, and it's not on the channels that I'm really concerned about right now.
Thank you very much, Trent. Next question here for you. When saying all Wi-Fi channels are scanned, are there any that may not be included within that list?
We actually allow the user to select which channels they don't want to scan. So if your customer or you are in an environment where that you don't use the Uni 2 and Uni 2 extended 5 GHz channels, you can say, don't even bother scanning them, I'm not using it. That's very helpful for because every single time a device is hunting for, or scanning all of the channels, it's spending time off a channel, right? It's on one channel at a time, taking steps across. So if you can say, I don't use these channels, don't scan them, that's helpful for you because it'll spend more time on the channels that you care about. Okay, so this is just kind of like saying, hey, we're gonna have this guy spend more time on the channels that I'm using, and that's gonna find the devices and get better insights about my network quicker and faster.
Thank you very much. Couple more questions. This next one is, are these channel reads always running or have to manually run for this information? If this chart was running real time, it would allow us to monitor this information a bit closer.
Will you read that first part again, just so I understand it correctly?
Oh, sure. Are these channel reads always running, or do you have to manually run the information? And then the second part says, yeah, okay.
I love this question, actually, because that is something that I care about. A lot of people have to say, all right, this guy is here, and it needs to be on this channel, and this one needs to be on this channel. And then what happens is the client device goes to a completely different channel. There is no manual thing that you have to do unless you want to omit channel. That's when you say, don't use these channels. But for the way that we've designed this tool is it works like a Wi-Fi scanner, but you get to click on things. So if you say, click on network 1, and network 1 is on 5 different channels. All of a sudden, these 2 adapters are going to split those 5 channels up automatically and just scan those. And let's say now you're looking at those 5 access points. Now you say, well, I want to know more about that access point number 5. We'll set this access point, one of the network adapters, to that channel, and then we'll have the other one going across all the other channels, within the parameters that you've set it to scan, and it'll do it automatically. Okay. Then all that data gets aggregated into a single capture file, of which you can export to Wireshark or whatever. But that's how the magic of the whole tool works. You click on a MAC address, we're going to take you to a client details page, and then we're following it forever until you click away. So it's very magic.
Very good. Excellent. Thank you. A couple more questions still here, Trent. Thanks for hanging in with us. Next question. Can you give us an example of non-Wi-Fi interference?
Non-Wi-Fi interference? Yeah, so
Yes.
some examples have already been asked about already. Most commonly, microwave ovens in the 2.4 gigahertz band is the most common occurrence. The next most common occurrence is probably analog cameras used for security reasons that transmit in the 2.45 gigahertz. All of these interfering devices, less common these days. And the other thing is like, if we look at what device manufacturers are doing, they are actually saying, hey, have this device prefer the 5 gigahertz band, which, way more spectrum than the 2.4 gigahertz. So it's easier to avoid interference. If you do find an interference, just don't use that channel. So you can mitigate a lot of interference related issues yourself, but if you can't avoid it, that's when this tool is going to be very helpful. So one of the things that in my previous roles was we would look at a whole large network and we would say, we expect 70 to 80% of our devices to be on the 5 gigahertz versus the 2.4 gigahertz. And that's because these devices are automatically preferring that band to the 2.4 gigahertz. 2.4 gigahertz, you're going to have a lot more interference. So if you or your client device have 2.4 gigahertz devices as a requirement, they can't do anything more, then you are going to really care about a spectrum analyzer in a very meaningful way, because you need to find those devices and get rid of them.
Thank you so much for clarifying all of that. Yeah.
Yeah, a key word here is IoT. A lot of IoT devices don't support 5 gigahertz. So if there's an IoT device that's having issues, spectrum analyzer is going to be very helpful.
Excellent. Thank you, Trent. Last question here for you. Can you give us an overview on your device's warranties?
Yeah, so it's a 30-day money back guarantee on the USB spectrum analyzer.
Trent, thank you so much for answering all of those questions for us this morning. And thank you to everyone for attending today. And if anyone has any further questions, of course, please feel free to contact your sales rep or email us at sales@microcomtech.com. And if you wish to view any of the products mentioned or shown here today, please remember that this presentation has been recorded and will be uploaded to our Microcom YouTube channel so you can view it again. Trent, we appreciate your time, all this incredibly valuable information that you've shared with us today. And we will discuss when we can do this again in a couple of months. We'll check our calendars and see when you'd like to share some more information with us. Thank you so much, Trent. Everybody have a wonderful day.
Thank you. Bye.
Bye-bye.